So, welcome to the lecture series on mathematical methods and applications. So, we were discussing Fourier series. I told you that a periodic function fx, if satisfies some properties like piecewise continuity and left and right hand derivative exists at each point, then fx can be expressed in terms of sine and cosine series. That is, fx will be something a naught by 2 plus summation a n cos n pi x by l plus summation b n sin n pi x by l, that I already told you, and we have also solved some problems based on that. Now, the next is complex form of Fourier series. What is that and how it is important, let us see. Okay. Now, Fourier series of a periodic function fx of period 2l is given by this expression, this we already know. This can be expressed in complex form, which sometimes makes calculation easier in the problems. So, why we need complex forms? Because sometimes it make our calculation easier. Okay. Now, how we can convert this form into a complex form, let us see. Okay. So, what fx is? Fx is nothing but fx is equal to Fourier series expansion is a naught upon 2 plus summation n varying from 1 to infinity a n cos n pi x by l plus b n sin n pi x by l. Interval is, we are taking interval from minus l to plus l. Okay. This interval we are taking, and fx is a periodic function. So, this is a Fourier series expansion of the function fx. Now, we know that e ki power iota theta is nothing but cos theta plus iota sin theta, this we already know. Okay. And e ki power minus iota theta is nothing but cos theta minus iota sin theta. So, when we add these two, we already know that cos theta is nothing but e ki power iota theta plus e ki power minus iota theta upon 2, and sin theta is nothing but e ki power iota theta minus e ki power minus iota theta upon 2 iota. So, these things we already know by the complex numbers. We already know that cos theta is nothing but e ki power iota theta plus e ki power minus iota theta upon 2, and sin theta is given by this expression. So, let us apply these things over here. It is cos theta, theta is nothing but n pi x by l, and sin theta. Okay. Let us apply these expressions over here. So, it is equal to a naught upon 2 plus summation n varying from 1 to infinity a n. So, what is cos n pi x by l by this expression? It is nothing but e ki power iota n pi x by l plus e ki power minus iota n pi x upon l upon 2, and plus b n into summation is over entire bracket. So, b n is nothing but b n into sin theta is e ki power iota, theta is n pi x upon l minus e ki power minus iota n pi x upon l upon 2 iota. So, this we can do. Okay. Now, this can be further written as a naught upon 2 plus, now e ki power iota n pi x by l is here and here also. Let us combine these two terms and again combine these two terms, e ki power minus iota n pi x by l here and here, combine these two terms. So, what we obtain? We obtain summation n varying from 1 to infinity, it is a n plus b n upon iota whole divided by 2. Okay. And e ki power iota n pi x upon l. So, we also know that 1 upon iota is nothing but minus iota, because iota square is minus 1. So, this 1 upon iota can be written as minus iota. Okay. So, this is nothing but minus iota, this we can easily write, okay, because of this property, plus again it is a n and again 1 upon iota is minus iota, minus minus plus, it is plus iota bn upon 2 times e की power minus iota nx by n pi x by n pi x upon L. Okay. So, these are the expressions which we obtain over here. Okay. Now, let us simplify it. So, this is, suppose this a naught upon 2 is c naught, okay, plus summation n varying from 1 to infinity. This, suppose this term is nothing but suppose Cn e की power iota n pi x upon L plus, and suppose this term is c minus n, it is a simply a notation c minus n e की power minus iota pi x upon L. So, what is Cn? C naught is nothing but a naught upon 2, Cn is nothing but half of an minus iota bn, and c minus n is nothing but 1 by 2 an plus iota bn. Okay. So, one can easily see that if this fx is a real function, if this fx is a real function, then these coefficients will be real, then this Cn minus is nothing but Cn bar. One can easily see these things because its bar is this, these are the conjugate of each other. Okay. If f is real, this is this if f is real. Okay. Now, this can be further written as c naught plus summation, it is Cn e की power iota n pi x upon L, and we can write, because all the plus values of n are covered from here and all the negative values are covered from here, okay, because instead of n we have minus n. So, we can easily write this as n from minus infinity to plus infinity, because n from 1 to infinity is here and n from minus infinity to minus 1 is here. Okay. So, and okay, and C0 will also disappear, because when n is 0, it is nothing but C0, C0 will also comes here. So, when we combine all these terms, it is nothing but n varying from minus infinity to plus infinity Cn e की power iota n pi x by L. So, this is the complex form of the Fourier series. So, Fourier series can be represented in this way or in this way, okay, both ways, both are equivalent. Okay. So, this is a complex form of Fourier series. Now, what are Cn, how we define Cn? Okay. Cn is given by, Cn is what? Cn is nothing but 1 by 2 an minus iota bn, it is equal to 1 by 2. What is an? It is 1 by L integral minus L to plus L fx cos n pi x by L into dx. Okay. This is by definition of an. Okay. And minus iota times, what is bn? Bn is 1 upon L integral minus L to plus L fx sin n pi x upon L into dx. So, this entire expression can be rewrite as 1 upon 2L integral minus L to plus L. You can take fx common. So, this is nothing but cos n pi x upon L minus iota sin n pi x upon L and whole into dx. So, this can be further written as 1 upon 2L integral minus L to plus L fx e की power minus iota n pi x by L into dx. So, this will be Cn, where Cn is nothing but this value. And what is C minus n? C minus n, if you evaluate, So, that will be nothing but C minus n will be nothing but 1 by 2 a n plus iota b n, using the same steps, following the same steps. So, this is nothing but, when we simplify it, it is nothing but 1 by 2 L integral minus L to plus L f x e की power iota n pi x by L into dx, because in this we have only the positive sign here instead of this negative. This is positive, this is positive, this will be positive. Okay. So, C minus n will be nothing but simply replace n by minus n in this expression. In this expression, simply replace n by minus n. Okay. And what will be C naught? C naught is nothing but a naught upon 2, and a naught is nothing but 1 by L integral minus L to plus L f x dx. So, that means when you replace n by 0 in this expression, you get C naught. So, if you find C n, so it contains C minus n also when you replace n by minus n, and it contains C naught also when you replace n by 0. Okay. So, that means when we write the Fourier complex form of Fourier series, which is given by this expression, f x is equals to summation n varying from minus infinity to plus infinity C n e की power iota n pi x upon L, and where C n will be nothing but 1 by 2 L integral minus L to plus L f x iota n pi x by L into dx. Okay. So, that will be the complex form of Fourier series. Okay. It contains negative C n also, which is also covered here. It contains C naught also, which is also covered here. So, we can easily write that the Fourier series, complex form of Fourier series, given by this expression, where C n is given by this expression. Okay. So, this is the complex form of Fourier series. Now, let us solve few problems based on this. Now, let us try these two problems based on this. Now, from the first problem, f x is what? F x is e की power minus x. Okay. And the function is defined from minus pi to plus pi. Of course, function is periodic. Okay. Now, we have to express this function as a complex form of Fourier series. Okay. So, how can we do that? We first find C n, okay, which is given by this expression, and when we substitute C n over here, so that will be the complex form of the Fourier series expression of this function f x. Okay. So, what is C n? C n will be given by 1 by 2 L, here L is pi, 1 by 2 pi integral minus pi to plus pi, f x is e की power minus x into e की power minus iota n pi x by pi into dx. So, pi cancels out. Okay. So, this is nothing but 1 upon 2 pi integral minus pi to plus pi e की power minus will be outside, and 1 plus iota n into x into dx. So, this expression we will be having. So, this is further can be written as 1 upon 2 pi. Now, when we integrate this, it is nothing but e की power minus 1 plus iota n x upon minus 1 plus iota n, and x is varying from minus pi to plus pi. So, this will be further equal to 1 upon 2 pi. You can take this term outside. So, this is negative of 1 plus iota n, upper limit minus lower limit e की power minus 1 plus iota n into pi minus e की power minus plus 1 plus iota n into pi. Okay. This we can simplify very easily. Now, multiply this by this conjugate 1 minus iota n. You can multiply and divide by 1 minus iota n. So, we will get minus 1 minus iota n upon 2 pi into 1 plus n square, and here when you simplify, so this is nothing but e ki power minus pi into e ki power minus iota n pi minus e ki power pi into e ki power iota n pi. Okay. Now, what is e ki power iota n pi? E ki power iota n pi will be nothing but cos n pi plus iota sin n pi, and it is minus 1 ki power n, and it is sin n pi is 0. And similarly, when you find e ki power minus iota n pi, that is nothing but the conjugate of e ki power iota n pi, so that will be remain minus 1 ki power n. Okay. So, from here what we obtained, it is equals to minus 1 minus iota n upon 2 pi 1 plus n square. When you simplify this, so this is also minus 1 ki power n, this is also minus 1 ki power n, both will come out, and what we will be having e ki power minus pi minus e ki power pi and whole multiplied by minus 1 ki power n. So, this negative you can get inside and upon 2. So, this will be nothing but when you simplify further. So, it is nothing but 1 minus iota n into minus 1 ki power n upon 1 plus n square, which we are obtaining from here, into pi, and this nothing but it is sine hyperbolic pi, because sine hyperbolic pi is e ki power pi minus e ki power minus pi upon 2. So, that will be Cn. Okay. So, what will be the Fourier series expression of this function? The Fourier series expression of this function f x now will be nothing but f x will be equal to summation n varying from minus infinity to plus infinity. Cn is what? Cn is 1 minus iota n minus 1 ki power n upon 1 plus n square into pi sine hyperbolic pi into e ki power iota n x. So, that will be the Fourier series, it is equals to e ki power x, okay, because we find the Fourier series complex form Fourier series of this function. So, function is e ki power minus x, okay, and that e ki power minus x, the complex form of this is nothing but this expression. So, that is how we can find out the complex form of a Fourier series of a function f x. Okay. Now, let us solve next problem. So, again we have to write down the complex form of Fourier series of this function now. So, what is the how the function defined is defined now? Function is f x is equals to, it is minus 1 when x is varying from minus pi to 0, and it is 1 when x is varying from 0 to pi, and function is periodic with period 2 pi. Okay. Now, again to find out the complex form of this f x, first we will find Cn, which is given by this expression. Okay. And after finding Cn, we will substitute it here. So, that will be the complex form of the Fourier series of this function f x. So, what is Cn? Now, Cn we can find out, it is 1 upon 2 pi, because L is pi, minus pi to plus pi f x e ki power minus iota n pi x upon L into dx. That is nothing but 1 upon 2 pi. Now, you can split this function, because function from minus pi to 0 is minus 1, and from 0 to pi it is 1, and it is periodic. Okay. One branch is in the negative side of x axis, one branch is on the positive side of x axis. Okay. So, this is minus pi to 0 minus 1 e ki power minus iota n pi x upon L dx plus 0 to pi it is 1 into e की power minus iota n pi x upon L into dx. Now, this can be written as 1 upon 2 pi. Now, you can integrate it minus e की power minus iota n pi x upon L. Okay. Here L is pi. Okay. Here L is pi. So, this is pi. So, pi cancels out. Okay. So, you can eliminate this. So, this is this and this is this. Okay. Minus iota n x, because L is pi. Okay. So, this is this function now, this is n x and divided by minus iota n from minus pi to 0 plus it is e की power minus iota n x upon minus iota n from 0 to pi. It is further equal to, now negative negative cancels out, it is 1 upon 2 pi. Now, you apply upper limit minus lower limit. The upper limit is 1 upon iota n will be outside, upper limit is 1 minus e की power iota n pi, okay, and it is minus 1 upon iota n will be outside, and it is nothing but when it is pi, it is e की power minus iota n pi minus 1. Now, it is further equal to 1 upon 2 pi n into iota, it is 1 minus e की power iota n pi minus e की power minus iota n pi minus minus plus. So, this is nothing but when simplify this. So, it is 2 times of this, 2 to cancel out, so it is nothing but 1 upon pi n iota and 1 minus e की power iota n pi. Okay. Okay, it is not 2 times. Okay. So, it is 2 into minus e की power minus iota n pi. So, 2 is remaining here. Okay. Now, e की power iota n pi is cos n pi plus iota sin n pi, which is minus 1 की power n, and this value is again cos n pi, this value is what, e की power minus iota n pi will be nothing but cos n pi minus iota sin n pi, which is nothing but minus 1 की power n. So, this is minus 1 की power n, this is minus 1 की power n. So, now it is 2 times, 2 to cancels out, and 1 upon iota is nothing but minus iota. So, it is minus iota upon n pi, and it is 1 minus 1 की power n. So, this will be the final expression for Cn. Okay. You can see when it is, when n is even, it is 0, and when n is odd, it is 2. This inside bracket expression, the expression inside the bracket. When n is even, minus 1 की power even is 1. So, 1 minus 1 is 0. When n is odd, it is 2. So, what will be the complex form of Fourier series for this function? So, for this function, the complex form is given by f(x) will be equal to it is summation n from minus infinity to plus infinity. Cn is what? Cn is minus iota upon n pi 1 minus 1 की power n into e की power iota n pi x upon L. So, this will be the complex form of this Fourier series. So, hence whether a function is continuous, like the first example is continuous, the second example is discontinuous at x equal to 0. So, if we have functions whether continuous or discontinuous, or I mean piecewise continuous, the second example is piecewise continuous. So, if we have such problems, then problems can be either converted into the sine or cosine terms as we have done before, or in the complex form of Fourier series which is given by this expression where Cn is given by this expression. Okay. So, here the benefit is we have to find only Cn, and there we have to find A naught, An and Bn, the 3 coefficients. Okay. So, that is how we can find out the complex form of Fourier series of any function f x. So, thank you.